Good afternoon, everybody. So I'm Akshay from L&T Technology Services, and I have with me today Samir, who's on the front seat, who's our Chief Marketing Officer, and I have NR as well, who's our Chief Digital Officer. Very quickly, just to give you a background, I'm an electrical engineer, and I'm really excited to be representing our company that has over 14,000 engineers. So unlike a lot of other companies that look at digitalization from a software perspective, we look at digitalization from an engineering perspective. That's the difference that we bring to the table. And very quickly, before I move on to what we want to talk about today, I want to give you an overview of what we do in the smart manufacturing space. So we help our customers in 4 areas, depending on their level of maturity. So the first one really is connect and collect. So, you've got so many different devices in the manufacturing space. You've got so many different kinds of equipment. It's really important to make everything heterogeneous so that they all speak the same language and it's seamless to integrate the data. So that's what we do at level 1. And once you've got that, then we help with what we call track and trace. So many companies today, they've got mergers and acquisitions, they've got so many suppliers, they've got so many customers. It's very important to ensure that everything can be tracked seamlessly. So that's what we do at level 2. And once we have that, where you've got so much of data, I think it's very important to kind of analyze all that data. Right? That's what we do at the 3rd level, where we're figuring out how much data to collect, what to collect, when to collect, and how can we align them to business goals so that they become relevant to that particular organization. And at the final stage is what we call a complete backward integration with the supply chain, with the logistics, so that you have something that's as close to a real-life digital twin as possible. Right? So what I want to talk to you about today, and I think we're very excited to talk about, is what we call Factory D.0. And these are a set of smart factory solutions that we've developed in collaboration with our smart manufacturing partners. So very often what we've noticed with our customers at least is that although they're all doing digitalization in some form or another, they haven't really figured out the right use cases. Right? So it's not aligned with the business goals. It's not aligned with efficiency, profitability, whatever it is that the organizations are looking for. And so because of that, you have something that's called mediocre ROI, and people are not really happy with it. And so what we've done, which was really a 3-stage process, we went in and we first of all did a complete benchmarking analysis of that particular manufacturer to figure out where they were in terms of digital maturity. We then went in and did a complete analysis of their gap areas, of the opportunities. And then we followed that up with a proof of concept. And the 5 things I'm going to talk to you about, which are what we call part of our Factory D.0 solutions. The proof of concepts we've done for our customers, global manufacturers, and they've given some stellar, mind-boggling results to them. And where we need your help is to put this out to the market and let people know that these are solutions that really work, they make business sense, and people need to start adopting them. So the first thing that I want to talk to you about is what we call wireless material tracking. So a lot of manufacturers are, concerned about connecting everything within their plant, within their factory, but they're not looking outside of the factory, right? Because if you have to have an efficient manufacturing system, you've got to look at connecting your supply chain, at connecting your logistics. So what a global aerospace manufacturer, a customer of ours, the problem that they had 3 problems actually. A, they didn't know where their order was. B, they didn't know when to order what. And C, when they had problems with their supply chain where the materials were not quite right and there were quality control issues, they weren't able to track and trace which supplier it came from and which process went wrong where. That resulted in that particular error. So they kept having that problem again and again and again. So what we did with our wireless material tracking solution was that we helped solve each of these things. First of all, what did we do for where their order was? We kind of fit in RFID tags into their entire supply chain so they could seamlessly track where their order was. on when to order, we kind of integrated that with market data. We integrated that with the production schedules so that everybody was speaking the same language, and then they kind of knew what to order where and how to order it most effectively. And when it came to their entire supply chain, the track and traceability, what we were able to do was that we were able to integrate their supply chain's processes with their major database. So when there was a problem with a particular raw material, with a particular component, they were immediately able to figure out that this was wrong because this supplier was doing this particular process incorrectly. And so they were able to fix that right then and there, and they didn't have recurring issues because of it. And just in the first year, in one production line, they were able to give us savings of over $100,000. And their parts availability went up 40%, the productivity went up 30%. And now they're implementing this solution in their entire plant and also in the other plants that they have. So moving on from material tracking is quality inspection. A lot of customers that we have, at least, they're still doing quality inspection manually. And doing quality inspection manually is obviously prone to errors. It also takes a lot of time, right? So what we thought about doing is, how do we automate this whole thing? And how do we make it relevant to that particular organization? So we're not just looking at, so I think what a lot of people do is when they talk about quality inspection, maybe they're doing a little bit of, measurement analysis. Maybe they'll do 3D depth analysis and they'll figure out if the product is of the right shape, the right dimensions, right? But what we did is we also looked at other things like weld quality, because when you're doing it manually, very often you're not able to figure out whether your weld quality is perfect or not. And then it goes way down to your production line, and then you figure out, and then there's rework and there's wastage. There's all of those problems, right? So we looked at weld quality, we looked at paint quality, we looked at minor scratches that you might have on the surface, which is very important, especially in consumer electronics, right? And just like any other machine vision system, this wasn't perfect to begin with. There were errors, and we had to do a lot of fine-tuning. We had to do a lot of CIP. But I think over the past 2 years, with all the CIP that we've been able to do, I think we've got it to a point where it's very mature. And now we've been able to automate a whole bunch of the processes where you don't need too much of manual intervention anymore. And so I think just about 2018, the results that they've had, again, in just one production line, is savings of $150,000, and the reject rates have gone down 20%. And so now they're looking at implementing this for their other manufacturing plants as well. Now, moving on to my favorite part, which is the digital twin. A lot of people are doing digital twin, but they're only doing it at a product level. So what we thought about doing is a digital twin at an entire factory level. And doing a digital twin for a factory can be extremely complex because you've got so many things out there, you've got so many processes, you've got so many different dimensions out there. So I think the trick is to figure out what you want to digitalize and what you don't want to digitalize. So what we did for an automotive company was we went and asked them, what are the most important parts in your manufacturing setup that you feel need efficiency improvement, that you think can be made better? So we went and digitalized only those things. What I'll do is I will quickly show you a simulation. So this is something that we did for a confectionery manufacturer. And this is just part one, which is basically simulating all the important parts in their factory that they wanted to optimize, that they wanted to make better. And once we were able to do this entire simulation, we fed in real-time factory data into the simulation model. We did it for two reasons. One, obviously, to verify if our digital twin worked, if it gave the same kind of reliability and efficiency results that you would get in a real plant. But more importantly, it also gave the plant managers the ability to figure out in real time what the inefficiencies in their manufacturing plant were. And they were able to run a lot of what-if simulation scenarios. So they said, okay, if I want to do 200,000 components of this in a day, and if I have 20 robots, how would it look like? If If I had only 10 robots, how would it look like? So they were able to take out things that they might not need in a plant. They were able to add things that they probably couldn't figure out before, and they were able to club things together. And the results have been awesome. Just in the first year, they've gotten a savings of over $1 million because of this digital twin. And we believe that, over time, as as plant managers get better at using digital twin, as they get better at maximizing value out of the digital twin, the results are just going to get better and better and better. And now moving on to what we call the paperless factory. So as a lot of manufacturers are moving into digitalization, they've got change management issues because a lot of workers out there, they're not really comfortable with the new processes, with the new systems. There's a resistance to change. And even if they do change, there's a lot of errors. It takes a lot of time to train them. That's where we came up with a mix of augmented and virtual reality to give these guys step-by-step instructions on how to do their entire manufacturing. And what's unique about this solution is not just the step-by-step instruction, but also the fact that it's able to track every activity of the worker. So it's got a smart camera technology, and that's able to track every single movement that the worker does, and it's able to raise alarms if they're not doing it properly. And that was huge for these guys because the amount of rework that they were able to save, the amount of productivity that they were able to gain was massive at just the proof of concept level. And now moving on to the last part, which is biomechanical models for product testing. So let's take an example where you've got a commercial vehicle and you want to design an ergonomic seat for that commercial vehicle, right? So how would you do it traditionally? You're going to get maybe hundreds of thousands of drivers with different shapes and sizes, and you're going to, calculate the stress factors. You're going to figure out how comfortable they are. You're going to do a detailed benchmarking analysis. So it takes time, and it's really not fun because you're not going to do it only for one product design. You're going to do it for multiple different designs, and then figure out which one is most ergonomic, right? But what if you could make a biomechanical model of that truck driver? Right? You can make an accurate biomechanical model of them. Then you don't need to have thousands of people to come and sit in your seat and figure out how comfortable or ergonomic it is. Because you can just take that biomechanical model and you can stretch it, or you can contract it, or you can elongate it. You can do all of those things, and you would get 1,000 or 2,000 or 5,000 or 10,000 different use cases just like that. And you can do it for multiple different designs that you have. It's quick, it's smart, and it works. So a commercial manufacturing customer that we have, a commercial vehicle manufacturing customer, they've already rolled out 2 designs in the market using this particular technology, and now they want to expand it into more products that they have. And we see huge potential of this across many different industries. So so as I said before, these are all proof of concepts that we've done for customers, and we'd love for you to understand more about these solutions and take it to the market so customers can gain maximum value of digitalization. This is an app that we've put both on Google Play as well as the App Store. It's called LTTS Factory D.0. So you can download the app, and you can have a look at all these solutions that we've developed at the POC stage, the kind of results that they've had, and the entire journey that went along in making them. So great. If there are any questions now, we'd love to answer it. Yeah. We're at booth number 28, so please do drop by, and please have a look at the Factory D.0 demo. We're going to show you the app at the booth, and we'd love to answer any more questions that you have. Yes?